Okay, today we're going to be building a unit circle, and you probably have no idea what that is yet. So let's get started. We're going to start with a square and a triangle. And what I'm going to do is take this triangle, and I'm saying that every side is 1 unit. Because it's an equilateral triangle, and we remember from geometry, equilateral means all sides are the same and all angles are the same. So every angle is 60 degrees. Every side, we're saying, is 1 unit. And I'm going to take this triangle now and fold it in half. So it looks like this. This side is still 1 unit. This side is no longer 1. I fold it in half, so this side is now 1/2. Folding it in half, I've created a right triangle right here. I now want to find this side over here. Well, it's a right triangle, so I'm going to use my Pythagorean Theorem, which says side a squared plus b squared equals c squared. In this case, I'm just calling the side x. It's very difficult to see. So x squared plus 1/2 squared equals 1 squared. And when we square a fraction, remember, it actually gets smaller. 1/2 times 1/2 is 1/4. 1 squared is 1. And I want to solve for x. So I'm going to subtract the 1/4 from both sides, giving me x squared equals 3/4. If I want x, I've got to take the square root on both sides. So I get x equals the square root of 3 divided by the square root of 4. And the square root of 3 we cannot simplify, so we're going to leave it as an exact measurement, which is the square root of 3. Square root of 4 is 2. So I now know the length of this side is the square root of 3 divided by 2. So I know all 3 sides in this triangle. Okay, what I'm going to do with this triangle now, so let's take a look at our angle measurements. This angle over here was 60 degrees, because remember, that's the original angle from our equilateral triangle. This angle is 90. This angle up here, 2 different ways we could find this. If this is a triangle, the angles add up to 180, so 90 plus 60 subtracted from 180 gives me that this is a 30 degrees angle. The other way we would know it is we started out with a 60-degree angle, and I bisected that angle when I folded it in half. So that's 30 degrees. So I now have a 30, 60, 90 triangle. And I'm going to trace it on to this coordinate grid. This grid over here, x-axis, y-axis. And what I'm going to do is take this triangle, turn it on its side, put the 30-degree angle, the point of it at 0, 0. The hypotenuse is right here, and then the 90 degrees that's formed is over here. It's with the x-axis, and I'm going to trace it. Okay, I've traced that triangle, and again, let's mark our sides here. This side was 1/2, was the length of it. This side right here was square root of 3 over 2. That's 90 degrees. And this side was 1. Okay, now what I'm going to do is take this triangle with the 30 degrees, and I'm going to reflect across the y-axis. Again, keeping the long leg up against the x-axis. My 90 degrees is formed over here. And trace it again. Filling in our sides once we've traced it, the height, or what I'm calling the height right here, is 1/2. This leg was square root of 3 over 2, and the hypotenuse is still 1. I'm now taking that triangle, and let's call that 30 degrees right there, taking that triangle and reflecting it across the x-axis, and trace it one more time. Fill in our lengths and sides. That's 1/2. This is the square root of 3 over 2, and this is still 1 for the hypotenuse. And let's make one more reference triangle. This we reflect back, and we're going to trace it again over on the quadrant and label our sides. So that's 1/2, length was 1, and this was square root of 3 over 2. Okay, we've now drawn a little bow tie, if you will. using this reference triangle and just reflecting it all around. We're now going to do the same thing with our square. So let's come back to our square. So I'm taking my square and I'm going to, we know that all sides are the same on a square. So I could call this side, oops, if my pen works, X, 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 and X. So every side is the same length. I'm going to fold this diagonally from corner to corner, creating this new triangle. This is a right angle. And since it was a perfect square, I know these two angles will be equal to each other. So they have to add up to 90, so half of 90 is 45. We have 45 degrees angles there. And by definition, I'm going to say the hypotenuse is 1. Again, I'm just defining this. And if you notice, if I compare this to my other triangle, the 30, 60, 90, both hypotenuses are 1. And you can see that they are the same length here. So back to this triangle, I know my hypotenuse is 1. And by Pythagorean theorem, I also know that side squared plus side squared equals the hypotenuse squared. Well, my sides are the same, so let's solve for x. X squared plus x squared gives me 2x squared. 1 squared is 1. I need to divide both sides by 2, giving me x squared equals 1/2. And I've got to solve for x, so take the square root of both sides. So I get the square root of 1 divided by the square root of 2. Square root of 1 is simply 1. Square root of 2 we cannot simplify. However, we're not going to leave our answer like this because we don't leave a square root in the denominator. So to get rid of that or rationalize it, I've got to multiply by the square root of 2 over the square root of 2. 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 gives me square root of 4, which is simply square root of 4 is equal to 2. So this is the length of my side. And let's go ahead and fill that in on our triangle. So square root of 2 over 2, and this side is also square root of 2 over 2. And now we're going to do the same thing we did with our 30, 60, 90 triangle. We are going to copy this onto our coordinate grid, putting the 45-degree angle up against the origin, forming a 90 degrees angle with the x-axis, and trace it. And I'm going to trace it in all 4 quadrants. So let's go ahead and trace it. Once we've got this traced, I'm filling in all the measurements. So the legs of the right triangle are the square root of 2 over 2, square root of 2 over 2, and the hypotenuse was 1 in every case. This one is the square root of 2 over 2, square root of 2 over 2, hypotenuse is 1, and square root of 2 over 2. And notice that I am using the same color as my drawings just to try and keep straight which measurements go with which triangles. Now this triangle that we just traced was a 45-degree triangle. So from the x-axis, that reference angle is 45 degrees. Okay, and now we're going to do one more thing. I'm going back to my 30, 60, 90 triangle, but this time instead of tracing it with a 30 degrees angle formed with the x-axis, I'm going to rotate this and put the 60 degrees angle up against the x-axis and trace it. And again, I'm doing this in a different color. This time we're going to just go with green and trace in all 4 quadrants. Okay, I've traced that now into all 4 quadrants, and we're going to go ahead and label the sides. Again, this angle right here that's formed with our x-axis is 60 degrees, which means this is 30, but I'm not too interested in this angle. It's the angle formed with the x-axis I want. And the sides here, along here is 1/2. The height was square root of 3 over 2, and the hypotenuse is 1. So I'm labeling that for all sides now. This one is square root of 3 over 2 and 1, and square root of 3 over 2. There we go.